Hello, welcome to Stars, Cells, and God. This is the show where we discuss new discoveries taking place at the frontiers of science and the ones that have theological and philosophical implications, as well as looking at new discoveries that point to the reality of God's existence. I'm Jeff Zweerink. I'll be your host today as we explore fine-tuning design in the multiverse. But before we get into the discussion, I want to encourage you to subscribe to our channel, Reasons to Believe. Click on that bell icon so you can be informed of new videos. Learn more at reasons.org or follow us on social media at RTB_official. I'm excited about our show today because we're joined by a couple of special guests, Rabbis Elie and Rabbi Aaron Zimmer, and we are going to discuss fine-tuning in the multiverse. But before we get into that, I just want to throw it over to you fellows and just give you a little chance to introduce yourself to our audience here.
Okay, my name is Elie Feder. I grew up, I'm a modern Orthodox Jew, and I grew up in a family which had a strong balance of religion and science and the modern world. And I guess my upbringing was, I wanted to become a rabbi at an early age, but I also was always that kid who was into math. And as I grew up, I was I was advanced in math. And it became natural for me to pursue an advanced degree. So I ended up pursuing a PhD in math, and I studied something called break group cryptography. I'm currently a professor in CUNY, and I'm also a rabbi in a local yeshiva. So that's kind of my balance. It was strong, I spent a lot of time studying the Torah and Talmud. And I also spend time doing math research. I research something called graph theory. I write papers in that area, and I teach. And I'm very into teaching. And there's Aaron.
My name's Rabbi Aaron Zimmer. I also grew up modern Orthodox in a Jewish family, and I always, a little different than Elie, that I've always felt there was this tension between the modern world and the religious world. And, as I got older and older, I was trying to find ways to integrate that in different spheres, in particular in the intellectual sphere and the conflict between, or perceived conflicts between religion and science. I studied in college, I got a physics degree. And afterwards, instead of pursuing further graduate degrees, I went into commodities trading. Which was trading cotton and sugar and coffee and oil a lot, oil, gasoline, natural gas, things like that. And I, used the categories of physics and, the idea of modeling and quantitative modeling in order to try to model markets. And I also used what's called the Brisker method from studying Talmud that I learned from, as part of my rabbinical training, using the conceptual categories of the Talmud and finding relationships between the markets, applying the categories of physics and the Talmud to really financial markets. I did that for about 11 years. I was able to retire about 7 years ago and really devote my time to studying all different types of knowledge. The Talmud is a primary one in the Bible, but also physics and biology and philosophy and psychology and just all different areas of that are of interest to me, and now Elie and I we've been writing a book for over 12 years. We still haven't published. At the end of the day, it's become the podcast, Physics to God. We're presenting it in a podcast form and dialogue form of really trying to synthesize and integrate the idea of God together with modern science and show how the idea of God is something that naturally emerges when you study modern science in the proper way.
Well, no, I'm excited about our conversation. I've appreciated the chance to interact with you fellows over, just briefly over the past couple of months. And it seems like there's a good synergy between what you fellows are doing and what RTB is doing, because a lot of people do perceive science and Christianity, science and faith as in conflict with one another. And at the end of the day, they really aren't. And if God is who he says he is, we would expect there to be a lot of alignment in there. And I know you guys have done a lot of study on fine-tuning. And, I've done some research on the multiverse and fine-tuning. And so that's kind of where we're going to go today. I thought it'd be good if we could just spend some time kind of laying out what the fine-tuning argument is. As you guys articulate that, how does that look?
Okay. So yeah, it's fine-tuning the multiverse go hand in hand, and specifically, we'll get to later on, the multiverse we're concerned about is the one that explains fine-tuning without an intelligent cause. So really the basis of getting to the multiverse is fine-tuning. And we present fine-tuning. There's three different ways to present fine-tuning. We've discussed that before. But we'll present the way that we do it on in season 1 of Physics to God on the podcast. And we'll present it here in a pretty quick way. Basically, we start off with the key idea is fundamental. Is we're dealing with in physics the most fundamental things in the universe, the fundamental laws of nature, which means the things that can't be reduced to anything else. They're like the first principles of nature, of reality, let's say gravity, quantum mechanics. And they're fundamental particles, things that, everything can be broken down into smaller and smaller pieces. But eventually you get down to the most basic things like electrons and quarks, things like that. And when you analyze these things, it turns out there are qualities and quantities. The qualities are, for example, in gravity, masses attract, and the quantities are how strongly they attract. And those quantities are called the constants of nature. That's the background that you need to get to appreciate where fine-tuning comes from. Is there are these qualitative laws of nature which have quantities built into them, and the amounts, how strong the gravitational force is, how big an electron is, the mass of an electron, and those things are called the constants of nature. They're always the same. Every electron is as big as every other electron. Gravity always is the same strength, assuming the masses are the same. And the question becomes, how do you explain that? So go ahead, Elie.
Right. So the idea is that science is always, maybe there's a quote from Einstein that says, the goal of science is ultimately to explain everything we see into the most basic, simple components. And science is always trying to break everything down. And we've been quite successful. We have these two laws of quantum mechanics and of general relativity or gravity. And we've been able to explain everything in terms of these laws. And we've explained all the different substances in our universe as comprised of what we know as the fundamental particles. And that's great. But when you come down to it, we're ultimately trying to explain everything. And these theories are the qualitative components of these theories are great. We got these two theories. But you have these numbers which are added onto these theories. And this leads to something which Richard Feynman called one of the greatest damn mysteries of physics, which is, it is in his book QED. He wanted to know, how do we explain these numbers? So for example, one constant is known as the fine structure constant. It's related to the strength of the electromagnetic force, and it's measured to be, we know this number only through measurements. There's no way to explain it based on any theory, but we measure it to be 1 over 137.139999137. So some long, complicated number. And the question is, how do you explain a number like that? Again, science is always looking to explain things, and you don't want to just say that our universe is explained by these two beautiful laws, by general relativity and quantum mechanics, and also by these 25 or so numbers. These numbers are these fundamental constants. There's like 25 or so, depending on how you count. And Feynman's saying the mystery is, how do you explain that? Is the core basis of our universe just these unwieldy numbers, or is there some way to explain these numbers? And that's what he's saying is a mystery. This mystery has nothing at all to do with fine-tuning. This is a mystery of just science is trying to explain our universe and trying to break it down into simpler and simpler components. At the core of everything seems to be these 25 awkward numbers. And how in the world do we explain that? This is what we call the mystery of the constants.
Right. Well, and it's interesting. Interesting in your discussion of that, because that's roughly similar in age, but I think people who 80s, 90s, early 2000s, there was this idea that there's kind of this one unified theory that explains everything. There's nothing that you have to put in from the outside. And yet in the midst of all that, we've got these relatively large number of quantities that we just have to measure. There's nothing about the theory that tells us that. We just have to go out and measure it, and that's what it is. And I think this is what you're referring to in your discussion there. So,
yeah, exactly. And it's I think what a lot of people, when they think about fine tuning, they skip over the step of there's just this intrinsic problem. of 25 numbers that are your ultimate reality. They're the ultimate basis of all reality. They determine everything. These qualities and quantities, and these 25 numbers, that's the ultimate theory of everything. And yeah, you're right, Jeff. Like a person, in order to really appreciate what bothers physicists, what bothered Richard Feynman and Steven Weinberg and the great physicists of the 20th century and afterwards, is what bothered them is they're searching for a theory of everything, for trying to explain everything in as simple a way as possible. And 25 complex, arbitrary numbers, that it's just not what physicists are looking for in a theory of everything. And that was the mystery. And the key to the mystery to appreciate is to realize the problem is the numbers are arbitrary, they're random. How do you explain a number? 1 over 137. Where does that come from? Why is it 1 over 138? Why is it 1 over a million? It could be anything. It's just literally a number some of these numbers have no units. It's just a fine structure constant, is a pure number. So how do you explain that in any deeper way without just saying that's the way reality is? And that's where fine-tuning, this is where fine-tuning comes in. Fine-tuning says, listen, I have a solution to this mystery. And the solution is you're making a mistake because you think these numbers are arbitrary. And they could have just as well been, instead of 1 over 137, 139. But that's not true. If you change those numbers a little bit, you realize, make it 1 over 139, then you don't have atoms anymore, because the electron and the proton will no longer combine in the same way in order to form an atom. And if you change it, in a different way, you don't have stars, and you don't have, carbon and hydrogen and all more complex molecules. And you don't have, you change, the cosmological constant is a very famous example. You don't have galaxies. The whole universe collapses right after the Big Bang, or it expands too quickly to even form molecules or planets and stars and galaxies. And that's the idea of fine tuning, is appreciating fine tuning is not the problem. Fine tuning is the solution. It tells you the answer to this mystery is that these constants are not random arbitrary numbers that are bereft of any type of explanation, but rather these constants are specific values, or within at least a specific range of values, in order to produce a universe with atoms and molecules and planets and stars and galaxies and life. Because without these constants being within this fine range, which is called fine tuning, if you were to change them a little bit, you lose all the complexity, structure, and order of the universe. And that was the big clue, which points to the natural solution indicated by what is the cause of these constants.
That seems to have the flavor of the anthropic principle that has been bandied about, and I think that term gets misdefined or used in all sorts of different language. But it's basically, I know some people have said, okay, the reason why the constants have the values is that this is what it requires to produce human life, if you will, or life of some sort. And so, is that the kind of or the line of reasoning you're using there, or are you saying something different?
No, totally not. That's, the anthropic principle is something we think multiverse scientists say. So we're going to get to it, and we'll be able to point out the irony. We don't say that at all. It's true. If you don't have atoms and molecules, you're not going to get life. If there's no such thing as planets, you don't have life. If you don't have stars, you don't have life. No galaxies, no life. So life can only exist, and you can only have intelligent life if there's life. You can only have life if there's atoms and molecules and planets and stars. So the reality is fine-tuning is necessary for the entire complexity and structure and order of the universe, of which life and intelligent life is just one part of it. We do not think there's sufficient justification for saying the purpose of fine-tuning is life in particular, exclusively life. What you really have the right to say from the science, from logically, is that if it were that the fine-tuning is there for the complexity and order and structure of the universe, everything in all its grandeur, the universe as a whole, of which life is one part, a special part. Life is definitely special, and there is something special about it, but there's no real justification for saying the whole purpose of the laws of nature, the constants of nature, is just to produce life. It's to produce everything, and if you don't have everything else, you don't have life either.
So the idea is there's the fine-tuning that is necessary to produce some level of complexity. Not really. If I were to would it be accurate to characterize that position as you're saying, okay, there's fine-tuning necessary to produce complexity. The anthropic principle saying that it has to be for life is a larger extrapolation of that you're saying is not necessarily justified by just what we study in the physics. Is that a reasonable way to characterize your position?
Yeah, yeah,
Okay.
Exactly. So the idea is that since we see that the discovery, again, this was a scientific discovery, it's based on knowledge, that the values of the constants are not arbitrary as they had seemed, as Feynman seemed to think that they were. But science discovered that these values are specific values. 1 over 137.139 isn't just an arbitrary number. It's a number which is specifically necessary to be able to produce a universe which has complexity, which has, atoms and molecules and planets and stars and life. And the idea is that when we see that, we're looking to understand the cause of these values. When we realize that the values are not just any old values, but they're specifically those values which have a purpose, have the ability to produce, to unfold, to be able to yield our complex universe, that indicates that the cause of these constants is a cause which acts with a purpose, is a cause, a teleological cause, which has a goal and objective in mind. That is our complex universe, which is correlated with these values. And that's where we think that discovery indicates an intelligent cause, because an intelligent cause intelligence is like the ability to select one option from among many for the purpose of producing a goal. And since we see the values are specifically those values which are necessary to produce that goal, that indicates an intelligent cause.
So we've got the two issues there, or the two issues at play. One is that in our theory, there are these numbers that we just have to put in, and we don't have any really good explanation for why the numbers are the way they are. But then when we look at the numbers, we see a second quote-unquote problem, which is these numbers take on these kind of highly specific values that if they were different, the universe just wouldn't have the complexity, even just atoms, not life, just atoms and complexity that makes interesting things in the first place. And so those two things put together, it's not just, okay, there's this laws that dictates everything. Certain things are put in, and those things that are put in point to something that is purposeful. That's basically where we are in our discussion so far.
Right. It's that the numbers don't have explanations using the normal way that scientists like to explain things. So like they would like to explain these numbers by saying they derive from some deeper mathematical equation. Like, for example, like scientists are able to explain chemistry by saying they derive from the fundamental laws of physics. And then they want to say biology derives from chemistry, or astronomy is also a derivative of chemistry plus physics, all these different things. So scientists they're trying to derive more complicated laws and phenomena in the universe by showing that they're the result of simpler, more fundamental laws and just the logical consequences of the unfolding of those laws. And in that sense, you can't derive these constants. They can't be derived from some simpler, deeper mathematical fundamental equation. Like you said, they just have to be measured. You just have to measure them and say, oh, that's how heavy an electron is. But where does that come from? That's the mystery. Fine-tuning is knowledge. Fine-tuning is scientific knowledge that over time scientists accumulated, that if you change these numbers, then you don't get stars, you don't get atoms and molecules. That's a kind of scientific knowledge, which it does explain it, but it explains it in a different way than scientists are used to. That's not how scientists explain chemistry. Scientists explain chemistry by saying, well, because of physics, logically, and logical consequence of physics is you're going to get atoms and you're going to have chemistry. Now it's explaining the reason why you have these quantities of nature, the constants, in a specific way, is in order for the purpose of producing chemistry, to produce stars, to produce galaxies and life. It's a different type of it is an explanation. It solves the mystery, but in a surprising way that's different, because scientists felt they had banished teleology from the universe. Newton, that was the whole point of Newton, and I don't want to say the point, but Newton, Descartes, and the shift from Aristotelian science to modern science was, let's not explain things through teleological causes anymore. And all of a sudden, because of fine-tuning, and that's the only real way to explain and understand the values of the constants, there's no other way to explain 1 over 137 unless you realize that if it were different, you don't get a star. That's a new type of explanation. That's what
Right. Okay.
shocked scientists in 1998 with the cosmological constant, and that's what forces this new type of explanation, either an intelligent cause, which is what we're saying. We're saying that's the natural indication. There's an intelligent cause that set the constant for the purpose of producing atoms and stars and molecules, a complex universe. Or scientists have to have the anthropic principle, that it's all because of human beings in a certain sense, which
And the multiverse.
and the multiverse and anthropic principle. That's their it's their jam. That's how they do it. Yeah.
So if let's take this scenario where we're still putting these constants in, so we're still measuring the mass on electron fine structure constant, but we find that these constants have values, or if they have a great range of values, you still get everything that we see. Do we still have a fine-tuning problem or a problem there? Or, because there's a part to where as a scientist I would say, okay, the number was 5, but anywhere from 1 to 10 would have worked fine. So that really doesn't need an explanation. Even though I have to put it in, it still fits within, just kind of I've got a basic understanding of what's going on. So if we were to take all of these numbers that appear fine-tuned, a little bit larger, a little bit smaller, something interesting out of our universe disappears, do you still have a problem there in your assessment?
I would say that if basically you saw from almost, and this was the assumption when Feynman was saying the mystery of the constants in 1985 or whatever it is that, if it was instead of 100, 137, it was 100 and 1 over 190 or 400 or 2 million or whatever it is, it would just be, you have a little bit of the atom is a little bit smaller, the atom's a little bit bigger, the electron's heavier or smaller or whatever it is. So then, there's no fine-tuning problem. There's no fine-tuning solution. Then fine-tuning doesn't explain the constants, the mystery of the constants, because you still don't understand why is it 1 over 137. It could have been anything and nothing would have changed besides fundamental physics. You'd still have a chemistry and astronomy and biology and all these other things, just with bigger electrons. And that then there would be no fine-tuning, wouldn't be a solution to the mystery, and there would be no problem of fine-tuning because it wouldn't exist. The reason fine-tuning is a problem is because these constants, you can't change them by a lot. You can't. Some of them, it's a couple percent. The biggest example, the cosmological constant, 1998, it's fine-tuned to at least 90 decimal places, maybe 120. It's exceptional. I mean, that's it's trillion, 1 out of a trillion. Trillions, a lot of them.
Right. You
just want it by chance. So it's just not something that can happen by chance alone. And it shows that these values are significant. They're not arbitrary random values. But it's contingent on it being that the fine-tuning is within a few percent, and some of them it's even more exceptional than a few percent. And if it wasn't, if any random number would have worked, then fine-tuning, there's no such thing as fine-tuning, and you'd be stuck with the mystery of the constants. How do you explain these numbers?
Right. We think if you just had those numbers, you'd be left with them. If you didn't have the fine-tuning, you'd have a mystery. But if at that stage you'd say, oh, why is it 131 or 137? Because God did it. God said it that way. That we think would be like God of the gaps. There's no indication of God. Then you just be plugging a hole and saying it's God. That doesn't give you any insight. There's nothing which would indicate God. You just be left with a mystery. And like Feynman said, it's a mystery. And at that stage of the game, we think that has nothing to do with God. It's just a mystery. Maybe science will find what the significance of these numbers are. But science has found what the significance of these numbers are. We discovered these numbers are fine-tuned. That points in the direction of God. That's knowledge which indicates design, indicates an intelligent cause.
No, I appreciate that. And so if they could just be anything and you still get something interesting, then you're left with, okay, why these numbers? Well, we may not have an explanation. The fact that we've said, oh no, they need to be this very specific value, that's the interesting thing in your assessment, because that says, there's something more than just random mechanical processes. There's something purposeful going on. That's the basic argument.
Exactly.
Okay.
Right. And the basic argument is now you have knowledge about the constants. That's the one piece of knowledge you really know about them, is that they are specific numbers in order to produce something. And by formulating the fine-tuning argument in this way, of realizing fine-tuning is coming in to be a solution to the mystery of the constants, it highlights the fact that fine-tuning is knowledge. It's scientific knowledge. If scientists didn't know anything about nuclear physics, they wouldn't be able to tell us if things are fine-tuned. If they didn't know anything about stars and how stars worked and developed and evolved, then you wouldn't be able to tell me if it mattered if the fine structure constant was a little different. It's all based upon scientific knowledge. You realize this is not an argument of ignorance. It's not a God of the gaps argument. it's an argument from knowledge, that we have the scientific knowledge that explains why these numbers are that way. And they directly point to the idea of an intelligent cause that set them for the specific purpose of producing a complex universe. It shows you why, if you formulate fine-tuning in this way, it shows you why it's not a God of the gaps argument. If you just say fine-tuning, what these constants are so strange, where do they come from? Why are they fine-tuned? God, it just sounds like a God of the gaps argument. And that's why it's so critical to formulate fine-tuning in this with these steps, first based on the mystery, and then see fine-tuning coming in as the clue that solves the mystery. It highlights the fact that it's not an argument from ignorance.
Well, and I love the point, and I think that's worth emphasizing, that this isn't like, well, we've just seen this, we don't know how to explain it. This is what flows out of our understanding of why things are.
Yes.
And the more we know, the stronger that conclusion becomes. Not the more we've learned. It's like, oh, these things that we thought, or where we said God just gets smaller and smaller. It's like, no, the more we understand, the more he seems to permeate what we're finding in the creation. And I think that's I love the point you're making there. I think that's pretty profound.
Yeah, and as when the Higgs boson, we started this before they, again, 12, 13 years ago, before they found the Higgs boson in CERN, but the Higgs boson comes out, and that becomes another example of fine-tuning. As scientists learn more and more about the universe, you find out the fine-tuning becomes greater and greater, because the level of fine-tuning is limited by our knowledge. It is, as you gain more knowledge, you start to realize that certain things, if you change them, you lose critical parts of the universe. They don't work anymore. So yeah, it very much highlights the fact that fine-tuning is a product of knowledge, and as human knowledge increases about the universe, the knowledge of fine-tuning increases also.
So let's now shift the discussion a little bit now towards the multiverse, because I think it's really good that we laid out what is the fine-tuning argument, how is it formulated, what are we dealing with there, because as I've looked at science over, just kind of studied a little bit of the history, know a lot about the current. This idea of a multiverse is really a growing idea, and in fact, one of my first encounters where it was given scientific credibility, not just talked about in some sort of science fiction type way. It did seem to be an explanation, or at least you can talk about fine tuning, you can talk about a beginning, but if the multiverse, doesn't that just get rid of it all? So, as you see the multiverse developed, how has that influenced this discussion of fine tuning the way you've articulated it?
Okay, well, the first thing with the multiverse is we would never have even tried to write the book, the book there, or made the podcast if the multiverse wasn't a theory in science. Because I came across fine-tuning 15 years ago in Lee Smolens's book, Life of the Cosmos, and it was just an amazing thing. He believes in black universes being born in black holes, right? A different theory, but it just I just realized he lays out the whole problem of fine-tuning. I just realized this is incredible. This is far and away the best argument for God that I've ever seen. It was, in my opinion, was much better than the argument from biology and evolution. And it was, but how are you going to convince people of that? You can go around telling people there's this fine-tuning thing. It's like, they're going to say, well, I'm sure the scientists have some explanation for it. What are scientists saying? Scientists are atheistic, most of them, or at least they present themselves that way. So how are you going to convince people? And it was only once I read Martin Rees's book, Just Six Numbers. So, he goes through fine-tuning of 6 numbers. And then, it's like an incredible book. You think, wow, this guy's really, he really believes in God, But then all of a sudden, the last chapter of the book, he's like, well, how do you explain this? So he ends up with a multiverse. And you're just like, what? That's the first time I ever saw the multiverse, really. And I'm just like, that can't be real. This can't be a real scientist is saying something like this. And I told my friends, and they didn't believe me. They didn't believe that scientists are saying a multiverse. Again, it was over more than a dozen years ago. Right. It was much less popular back then. And we start to realize once scientists are saying that they believe in an infinite number of parallel universes that nobody could see, and these are real scientists, the top scientists in the world, that's a way to convince people that fine-tuning is a real problem. Because if scientists are saying the multiverse, and we'll discuss obviously the problems of the multiverse in a second, you can't just discard it, but if they're saying something like the multiverse, you can show people clearly what is wrong with the multiverse, and then they'll realize that fine-tuning is a real problem. And that's why we try to make the book. We had presented fine-tuning in series 1 of the podcast Physics to God to present. We just did quickly in past half hour. We did it much more lengthy analogies in the series 1. It's because of the fact that you can explain what the multiverse is and show people that that's just really not a very good theory. And that's what we're going to do in basically season 2 of Physics to God, which is just coming out at the end of this year in November, December time. So maybe we should discuss.
Talk a little bit about multiverse.
Yeah.
Go ahead,
Right. So basically, the argument as we presented it, we think the discovery of fine-tuning shows that the only way to explain these constants, these fine-tuned constants, is that there's some correlation between the values of the constants and our universe. Mm-hmm. And that's a problem for scientists. How in the world are you going to explain the values based upon the future result? So as we said, the standard, the implied interpretation is that God set the values in order to bring about that result. But the other way to explain it is the way of multiverse scientists, which is basically, we think, when we break down, again, it's one thing multiverse is used in a lot of different ways. And we think it's important to identify multiverse as an explanation of fine-tuning. There's a lot of different, and I think in Brian Greene's book about multiverse, he has like 10 different versions of multiverse. Right. We think ultimately every version of multiverse that explains fine-tuning demands 3 elements in order to explain fine-tuning. And we'll start by talking about the first 2 of them. The third is much more complicated, but let's start with the first 2. So the idea is that in order to explain fine-tuning without God, without an intelligent cause, you need to say the following. First of all, you have to have infinitely many universes. Okay, it means either a very, very, very large number of universes, or generally it's because the scientific theories that produce many, many universes is called as inflation. Right. So you need to have basically inflation naturally, at best, depending on how you model inflation, you end up with an infinite number of universes. So that's the first step. You have to have infinitely many universes.
Yeah, and the idea behind that, as I understand it, is, we've got all of this stuff. Effectively, what you're saying is all of that happened somewhere, and now we're just part of that distribution. So what we thought was this really rare, exclusive, or had to be this way is just one amongst the distribution. And the fine-tuning is so remarkable that distribution has to be really, really large.
Yes, exactly. So that it's very important that there's that second element. In order for that, what you said well, Jeff, but in order for that to make sense, you not only do you need many universes, you need these universes to be varied. You need them to be different. You need the constants in all these different universes to be different. If every single universe, if there are infinitely many universes, but every single one of them had the fine structure constant being 1 over 137, 139, then that wouldn't explain anything. So you've got infinitely many universes, and they're all fine-tuned, and they all point to a design intelligent cause. Right. So the idea is that you need to have many, 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 many universes, and each universe has different constants. Even though, as far as we could tell, the constants are constant and they're fixed, but multiverse has to posit that there are infinitely many universes, unobservable universes out there, and that the values of the constants in these different universes change from universe to universe. And the argument goes, if that's the case, that there truly are infinitely many varied universes, then you're going to, by chance, have anything happen. You're going to have the 131 or 137 just by chance alone in some universe. In fact, in infinitely many universes, you're going to have every single set of values. And there's going to end up being somewhere in this vast infinite multiverse, you're going to have a fine-tuned universe. And there are going to be people on that universe saying, hey, why are the constants so perfectly fine-tuned? What's the cause of that? But the argument goes, that's just because there's an observer bias, that the intelligent observers who are asking that question have to see a fine-tuned universe. If it weren't fine-tuned, they wouldn't be there in the first place. So that's kind of the way what we're going to call it. We call this the naive multiverse. We think this is, if we just have these 2 elements, we think that it doesn't quite work, but this is the basic idea of how multiverse attempts to explain fine-tuning, based on infinitely many universes and the fact that these infinitely many universes vary. The constants change from universe to universe.
So in essence, any rare event is explained effectively because it just happens somewhere, and which I find a very interesting way to explain scientific phenomena, in part because as I've just in my scientific career, what I realize is that that there's people have this idea that scientists go out and say, okay, here's my hypothesis, or here's the problem, here's the hypothesis, I test it, the experiment says yes or no, I modify the hypothesis, keep working. What really is going on in there is you're saying, okay, here's the best explanations, the one that are most likely, and as I go in and measure and as I confirm that says, yeah, that's most likely right, and if not, I've got to modify and look at some of the more less likely explanations. Which, if you're now saying everything does happen, there's no end to the less likely explanations you have to look at. Which is I think that's going to be incredibly detrimental to science. I'm curious your thoughts on that.
Yeah, for sure. It's if scientists were actually trying to explain things, you see, this is really a straw man version of the multiverse. Mm-hmm. There's one more element, but this is the way it's presented, and a lot of people speak about it this way, that you're just saying there's an infinite number of universes, they're all different, and then most of them are not conducive to intelligent observers, but intelligent observers can only exist in ones that are fine-tuned. So obviously we're going to look around and see ourselves in a fine-tuned universe. That's why the constants are fine-tuned. Mm-hmm. It's called, and that's the anthropic principle. That was the point I was making before. There's an irony is that, we're religious. We're talking about God, and we think it points to an intelligent observer. Sorry, intelligent cause. And we're saying that God set the constants for the purpose of creating the entire universe, mm-hmm. of which life is an important part, but not the only purpose of everything. We're not explaining the entire universe by recourse to human beings. It's for planets and stars and all complexity. But multiverse scientists are saying that the reason why we observe these laws of nature and these constants of nature, it's because we are only capable of observing laws that are fine-tuned and designed. And they're explaining our observations by making recourse to intelligent observers. So they're saying, yes, there are all these fantasy, mm-hmm. All these other universes out there that are different, but the universe that we see and observe is determined by mankind. And that's called the anthropic principle. Mm-hmm. And the irony is that atheistic scientists are using, human beings in order to put a constraint on the laws of nature and the constants of nature that we're able to observe. Right. And that's what I was saying is multiverse scientists use the anthropic principle to explain our observations through a selection bias, an observer bias. Well, when we're formulating in our series 1 of Intelligent Cause, we specifically didn't make human beings the ultimate purpose of everything. We didn't think there was justification. We weren't doing that. So there is this interesting irony of the whole thing.
But getting back to the point
if I could ask a question on that before we move on, it seems like there's this. Often the way I've heard the fine-tuning produced or explained is that, the universe has to be exactly the way it is or you wouldn't get humans in there.
Right.
If I get what you're saying, there's a little bit of there's a difference between it's fine-tuned, but there's almost something more for humans. It's not just fine-tuned for humans. That distinction is actually important because if it's fine-tuned and it has to be exactly this way for humans, then in some sense the infinite multiverse, if it exists, could explain humanity. But if the fine-tuning is such that having the fine-tuning almost isn't enough to explain humanity in some sense, if I get what you're saying, or am I reading something in there that's not there?
I'm not quite saying that.
Okay.
I'm more saying that you're trying to understand what is the purpose of mm-hmm. these constants. Why do they have these values?
Okay.
So a lot of people say that the purpose of the constants is in order to produce humanity. Mm-hmm. And they're right in the sense that if these constants weren't fine-tuned, there wouldn't be any human beings. But they're wrong by saying that therefore, I can say the purpose of fine-tuning is humanity. Because then, if you say too much, you end up with nothing. Because then somebody says, listen, there's the human louse, lice type of that a parasite on human beings. Mm-hmm. So if it weren't for these constants of nature all being fine-tuned, there wouldn't be any human lice. So the purpose of the whole universe is for lice. That's obviously ridiculous. So it's true that if you don't have atoms, you don't have lice. If you don't have molecules, you don't have lice. You don't have planets, you don't have all these lice. That doesn't mean the purpose of everything is lice. What you have the right to say is the purpose of the constants is the entirety of the universe, all the complexity and order and structure of the universe, of which humanity is but one part. And it's just critical not to overreach, because if you overreach and say, I've proven that the purpose of the whole laws of nature and the universe is mankind, so then atheistic scientists will have these types of questions on you. And it really comes from a failure to formulate the fine-tuning argument in a real rigorous way without grabbing too much. Oftentimes, religious people want to say that fine-tuning is specifically for intelligent life, because that really opens the door for the fine-tuning argument to really establish divine providence, that the intelligent cause of the universe specifically intended a universe for people. And then it becomes an excellent argument that God really cares about people, and he does specific interventions for mankind. And we're not arguing on that point. It's just that we're saying that you can't get that out of the fine-tuning argument unless you could show specific things of fine-tuning that are only necessary for mankind, that have no relevance on anything else in the universe. And that's, maybe carbon a little bit, but that's basically it. There's not much to really justify that.
So there's an aspect to where you're formulating the fine-tuning argument in a measured way that is robust and justifiable and doesn't have this other stuff that creates complications that are hard to justify scientifically, if you will. And makes it a more robust argument.
We're trying to show from the fine-tuning, from discoveries, that there is an intelligent cause to our universe. And that's unbelievable. If you could show that, if you could ground the idea of an intelligent cause, a cause that acts for a purpose based upon solid reasoning from modern discoveries of science, we think that's solid and that's robust, and it doesn't fall prey to a lot of the attacks which people raise against fine-tuning.
Right.
Very good.
Right. Once you establish the existence of God, then you can build upon that, and you can develop arguments for divine providence and for religion that comes after the fact. But we think there's this fine-tuning argument it's incredible. It's the best argument for an intelligent cause, for a God that is arguably from science ever. We think that's what's going on. That's why we're spending 12 years doing this, because this is special. This is different than everything else. And it's just amazing if you can have the idea of God emerge from science, and that being, that really should be accepted by scientists. And if you try to do too much and try to say, well, this is proving divine providence also, you lose the rigor and what you for sure could say from the fine-tuning argument. So that's why we're so careful about how we formulate it in our on our podcast, Physics to God, because we think a lot of people don't formulate it in the proper way, and then they expose themselves to certain questions, and it makes it seem like fine-tuning isn't a strong argument when it really is very much so.
No, I appreciate that clarification, and just thanks for that. I want to kind of go back. I know we were talking about you said that there were 3 requirements the multiverse had to have. One was the very large size, 2, that the laws of physics actually varied throughout there. You said that was kind of naive. So what's the third part that makes it less naive?
Okay, well, first let me point out what's naive. I think you were touching on the point, Jeff, about why is it naive just to say these 2? And the problem is that if you really want to explain, use the first 2 premises, use this idea that infinitely many universes which are varied, and anything is going to happen somewhere in the infinite multiverse, then you really could explain anything and everything. And that becomes like what we call like a multiverse of the gaps. You don't have to, all of science in a certain sense is you observe phenomena and you're looking to try to explain it. You find life. You say, how in the world are we going to explain the diversity of life? And science tries to come up with a theory of evolution to explain it. Well, you don't even need a theory of evolution. You could just say, look, there's an infinite multiverse, and in one universe, by chance alone, you're just going to have some quantum fluctuation of all of life. And in that measure, you could explain anything and everything. You don't need science anymore. You could just, everything will happen in an infinite multiverse. Another example is, we said, imagine you have a voice coming from the sky, and the voice would make a big announcement and say, I am God, I created the universe, I fine-tune all the constants of nature to be exactly this way for the purpose of bringing about our ordered, structured, complex universe. There's no such thing as a multiverse, it's all fake, it's all make-believe. What would a naive multiverse scientist say at that point? He'd say, wow, by chance alone, there's going to be one universe that's going to have a voice, a sound wave, a random sound wave of that type. it must be where it happened to be in that one universe. And the idea is that positing a multiverse where everything and anything and everything happens, and explaining the most random, the most far-fetched things, something like fine-tuning the most improbable things, based upon just saying, well, apparently we're in that one universe, is naive. You could explain anything that way.
Right.
You could even explain away the most damning evidence of your theory based upon this infinite multiverse. And that's the problem. And that's why we think scientists don't say this. They think people often present multiverse with these two elements, but it doesn't work because of problems like this. It doesn't, it's too much.
It's so ridiculous. Even scientists can't say it. And the key thing is, and now scientists do say that anything and everything happens in an infinite varied multiverse. Anything and everything does happen, and scientists say that, and that is absolutely true. That scientists believe that. The multiverse scientists really do believe that, and in multiverse, everything does happen. The problem is you can't explain things by saying that. If you explain things, then you can explain everything, and it's not a good explanation. And that's where the third component, the third element, premise of multiverse theory comes from. And if you think about it, okay, the third, let's first say what it is, and then this is the far and away the most complicated one, and it's critical. And again, multiverse scientists say they need this, and we'll explain it and where it goes wrong. But the third premise is the idea, it's called the typical universe premise. It's the idea that we live in a typical universe with intelligent observers. So I'll say it in a more abstract way, and then Elie will give an analogy.
Right.
We're going to do this in season 2 in a much slower way. I'll try to do it a little quickly here. Basically the concept is, so let's take a look at, if we can imagine in front of our mind's eye, all the different universes in the multiverse. So 99.9% of them do not have any intelligent observers because their constants are not fine-tuned, the laws of nature are not correct, the initial conditions are not good, and therefore 99.9% of the universes are filled with total garbage, chaos, nothing. Okay, so those, and scientists are absolutely, multiverse scientists are absolutely correct. You can't ask a question, well, why are we not in one of those universes? Because it's impossible for an intelligent observer to exist in a universe which is not fine-tuned. So, of course, that makes sense. But now let's take a look at all the other universes that have intelligent observers. They're not all the same. In fact, there's infinite variety of how you can get intelligent observers. You can have an observer which, exists like we do with 100 billion galaxies, 100 billion stars each, and billions of people on planet Earth. You could have, just one galaxy, the Milky Way, with billions of people on Earth. You could have just had a solar system. And you could have had, there's a lot of different ways. You could just have one person who randomly fluctuated. A brain, it's called a Boltzmann brain, in the literature, it's called freaky observers. So just fluctuations of people. So there's a lot of different ways, in an infinite way. You could have universes which have, dinosaurs on them, unicorns which have, Smurfs and unicorns and intelligent observers. So there's, and universes with voices from heaven. So every possible type of universe with intelligent observers exists in the multiverse. And an observer bias, the anthropic principle, isn't going to tell you which universe you find yourself in, because they're all perfectly observable. There are, according to multiverse, there are intelligent observers in all these crazy universes with Smurfs and unicorns who are looking around and going, hey, there's a unicorn there. That's kind of weird. Well, why do unicorns fly around in this universe? So they really exist according to multiverse scientists. And you can't say, well, how do you explain why we're in this universe and not that one? So that's called a typical universe assumption. If you think through the probability, according to multiverse, because multiverse explains things through chance and probabilities, they must say that we are most likely, we are in a typical universe with intelligent observers. If you're going to predict things through chance and probabilities, you have to predict that we are going to be in a typical, a mediocre, a probable type of universe with intelligent observers, and not in one of the rarer, atypical types of universe that also have intelligent observers. So I said that it's a little complicated, but
it seems like
Jeff, let Jeff go.
You're imposing a criteria that is somewhat scientifically unjustified, though. If I'm
Yes.
correct. I mean, I
No,
get
no,
that.
why? No, we're not imposing it. Go ahead.
Well, no. So to impose that, I'm not saying you are. You're saying these are the three things you need for your multiverse to be. But you're imposing a criteria that is, one, unmeasurable, and two, somewhat unjustified. So it's an interesting. I think it's a reasonable thing to say, but I don't know that gets you to the place where it's rigorous that you could compel somebody to believe that, I guess.
Okay, so let me just clarify what you mean. I think yes and no is both true.
Okay.
Is in order for multiverse to actually explain anything, they have to posit that we are in a typical universe with intelligent observers. That's if you're willing to just say anything that happens in the universe, and anything possible happens somewhere, and to explain anything that way, well, then you could explain that's multiverse of the gaps. In order for multiverse to actually explain our universe, you have to say that our universe is typical. That probabilities, you're trying to explain our universe based on chance alone. And that makes sense if our universe is the typical universe which has intelligent observers. That's what allows multiverse to make predictions. It allows you to do science. But now you're saying, Jeff, I think, that seems totally unjustified to suggest that out of all the universes in infinite multiverse that have intelligent observers, ours is typical. It doesn't seem like reasonable. You can't just wave your hands and say, yeah, our amazingly complex universe with 100 billion galaxies, 100 billion stars is the most typical way to get one intelligent observer. It would seem to be much more likely to get an intelligent observer just by having a Boltzmann brain, or by having life on Earth without having our massive, amazing universe with all the complexity. So is that what you're saying?
It's sort of like that. And I guess I would put it in the context of, people say, well, when we're looking for life in our universe, why would you assume it's like us? We would assume, it could be carbon-based, it could be not carbon-based, it could be floating in the atmosphere of Jupiter. Why are we restricting or having this human carbon chauvinism, if you will? But it seems like that sort of requirement has we're the expected, which is kind of what's been argued against in so many other places.
That's what I'm saying. That's the irony. The crazy irony here is that multiverse scientists have to say that we are a typical form of life in the infinite multiverse. This is a typical, expected, predicted. That multiverse would predict that something like us would exist. We're a common form of intelligent observer. And it's ironic because you've always heard them arguing against people who are trying to say, the fine-tuning for intelligent life. Again, we don't formulate that way, but people who do try to formulate it, fine-tuning for intelligent life, they're always saying there may be all these different types of forms of intelligent life out there. But again, that's if you formulate fine-tuning for intelligent life, you do run into that problem. But it comes back on multiverse. Now you ask the question on them: are we really the typical intelligent observer in a universe with intelligent observers? And they have to say, yes, we are. And how do they? Is that really true? And we have certain. How do you even figure that out? You can't look at these other universes. So how would you even figure that out?
Well, and I think that's an important point to emphasize too. Is like, at least when we're talking about could you have life that was based on something other than carbon, there's actual studies we could do to determine whether that's the case. The idea of life being different somewhere else, there's no way we can measure that because by definition, it's out in the multiverse where we can't ever contact with. And so it is a little bit of I appreciate the irony you're bringing up there.
I mean, it does turn out that you could actually make certain calculations and figure out what the typical observer in a multiverse looks like, which is amazing. It really is, because again, this is the prediction of multiverse of the multiverse. Now, before I just tell you what that prediction is, and they scientists have them, it's what's so important to appreciate this point is that you have to see why we're not making this up. Okay, we're not making up that the typical universe premise. Scientists say this, and also it's not being made up just to solve the problem of multiverse needs a prediction. Okay, it follows from the logic of multiverse. So Elie's going to give a little bit of an analogy. Okay, his famous marble analogy, and it will help clarify why it's a natural prediction multiverse. They're not just saying in order to solve problems, and we're not making it up. You'll see why it follows in the logic of multiverse. Okay, go ahead, Elie.
Okay, so imagine you have a jar full of marbles, okay? And the jar has, let's say, billions and billions of white marbles and one gold marble, okay? And at the bottom of the jar, you've got a little opening. And you randomly let out one marble. Now, if that one marble which comes out is a gold marble, is the one gold marble, you say, is chance a good explanation for how I got that marble? You say, there's no way. That's like 1 in a billion, billion, billion. That's crazy. There's no way. Chance is not an explanation. Rather, it must be that it was rigged, something like that.
Right.
Okay. Now, imagine I change the analogy a little bit. And now we realize that the marbles are not all the same size. The white marbles are all large. And the gold marble is small. And the opening, which lets out a marble, is medium sized.
Right.
So now the only marble that could possibly fit out of this hole is the gold marble. Well, now you don't even need chance. The only marble that could possibly come out is the white marbles are too large. And that's this idea that there's a selection bias, which would only allow us to get the gold marble. Then perfect, no problem.
Right. That's essentially the anthropic principle.
Right. Yeah.
Of all the universes, but you're only capable of observing one because of a selection bias.
Right.
Simply enough. Okay, fine. That's simple. Now go ahead.
Okay. Now let's change the analogy a little bit. Besides the one small gold marble, imagine you also have 1 million small silver marbles. So again, you got billions and billions of
trillions.
You got trillions of white marbles, large white marbles. Those marbles you can never possibly get. They're too big to come out of that opening. But now you have small marbles. You got one golden marble, and then you got 1 million silver marbles.
Right.
Yeah. And now all those marbles are all small, and they could all come out of that opening. Now, if you let out one marble, and that one marble is the gold marble, chance is not a good explanation because it's 1 in a million. Right. Chance, what I would predict would be the typical precious marble. The typical precious marble is silver. The odds are 1 million to 1 that I'm going to get silver over gold. And if I did get the golden marble, I would say chance is not a good explanation. Right. So while there is a selection bias that only allows us to get a precious marble, it doesn't allow us to get those white marbles, but it doesn't tell us that we should expect to get the gold marble as opposed to the silver. And if I do get the gold marble, well, I've got a problem. Chance isn't a good explanation for that. It's 1 in a million.
You predicted it predicted silver marble, right? This whole thought experiment predicts you'll see a silver marble because there's no selection bias between gold and silver marbles. Just like there's no observer bias between universes which have intelligent observers and 100 billion galaxies and Boltzmann brains that are just flowing quantum fluctuations in a bunch of chaos. There's no selection bias between those two. They're both intelligent observers. So the prediction is you'll come up with whichever is this 1 million silver marbles is your prediction. You'll get a silver marble. And if you get a gold one, you got a problem on your hands. That's a false prediction.
Right.
And that's the idea, is that our universe, multiverse, have to maintain that our universe is like a silver marble. If you're trying to explain our universe by chance alone, you have to maintain that our universe is like one of those silver marbles and not the golden marble. And that's really the question. Is our universe a typical, and that's the third premise, that multiverse scientists maintain the typical universe premise, that our universe is the typical universe of intelligent observers. It's a silver marble. Right. If, on the other hand, it would turn out that our universe is like the gold marble, well, then chance isn't a good explanation. The multiverse fails as an explanation.
Right.
It's interesting because as I've read some of the scientific literature, people who have, would argue that we live in a multiverse, however scientifically that plays out. There's often, there's got to be some sort of measure, there's a measure problem. And so you got to have these cutoffs cutoff is not the word they use. I'm drawing a blank on it.
Yeah, cutoff. They use cutoff.
It's like, say, okay, so these are the kinds of multiverses that don't exist, or you can't have that. But it seems like that almost plays the criteria of the measured parameter, if you will, in some sense, in that you're effectively fine-tuning which multiverse models are good. And so it seems like you almost end up with another form of the fine-tuning argument in looking at that. And I find that interesting.
So you're one step ahead of us. You're already at the measure. The measure problem is the next step, which ultimately knocks off multiverse completely. Okay, but we're not there, one step away here. We're gonna get to that. That's the next thing. Right before we get to the measure problem, and now that is the biggest problem, like you said, the measure problem. But just naturally, just to see that it predicts we're in the typical universe. Right. Now, what is the typical observer? It comes out the typical observer is a disembodied brain floating around, and there's trillions and trillions and trillions of more of universes which just have one brain surrounded by chaos. And this is based upon, entropy or just, probabilities. Then universes like our own, just for our universe is such a unlikely universe because of its highly improbable initial conditions and the complexity in all the galaxies that you have in order to get human beings. And it's not something. It's much easier just by probabilities, by chance alone. If you're going to have a fluctuation, produce a single brain that exists for a second and then it flips out of one moment later out of existence. So it comes out that it's highly improbable to have a universe like our own, and the typical observer should really be a Boltzmann brain. And you could actually do that calculation. It's just based upon entropy. That we are not a typical observer, and that's a major problem for multiverse scientists. Multiverse does make a prediction, and it turns out that prediction is wrong. And our universe is the golden marble, and it's not like one of the silver marbles.
Right.
That's a big problem.
Well, and I would emphasize it's not like those are complex, hard calculations. Those are pretty straightforward thermodynamic calculations. I mean,
right, because the odds of getting an entire universe just by fluctuation with hundreds of billions of galaxies versus a single little brain that just has the thought of false memories and then fluctuates out of existence. It's not even close. It's the orders of magnitude are just astounding. So it's not a complicated equation at all. So that's the problem of appreciating that if scientists try to explain fine-tuning by saying there's an infinite number of universes and they're all different with different constants, and then we just happen to be in a universe which has fine-tuning because that's the only one we can observe. If they just say that because everything and anything happens in multiverse, that's not science. Then you predict voices that come from heaven and seas splitting in front of people and resurrection of the dead. Then all those things really do exist in a multiverse. And then you're going to say, well, scientists can explain that too. And that's not good science. Nobody really wants to say that.
Right.
But multiverse scientists add this additional requirement. They say it themselves. Vlenkin calls it principal mediocrity. And that we live in the typical universe with intelligent observers. That is a type of a prediction, and therefore we wouldn't predict to see flying unicorns and Smurfs running around, but that's good for a multiverse. It doesn't predict that, and we don't. On the other hand, it predicts that we would be Boltzmann brains, and that nobody is real, and we're just little fluctations, which is possible, but it has its own associated problems, and that seems to be a false prediction. So that's one problem.
Right.
The deeper problem is what you alluded to before. It's called the measure problem.
Right. So the idea is that the problem altogether is, what does it even mean to say that we're a typical universe? The way you figure out what a typical marble is, for example, is you count up, well, how many gold marbles are there? How many silver marbles? And there's a million silver marbles and one gold marble. So you say the probability of getting a silver is higher than the probability of getting a gold. Now that works when you're dealing with finite sets.
Right.
You count them up. But the problem is that the only way to model to have so many universes is eternal inflation. And eternal inflation predicts infinitely many universes. It says that there are infinitely many universes. Now, what does it mean to calculate probabilities in an infinite universe? The set of universes is infinite. The set of universes like ours is infinite. Everything's infinite. How do you even make a calculation? Imagine, again, it would be like you had infinitely many silver marbles and infinitely many gold marbles, and you pick one out. What's the probability? What sense would there be to saying that the typical universe is gold or silver or anything? So how do scientists even make a claim that our universe is typical?
Right. And the key point is to realize multiverse scientists, real multiverse scientists, don't just believe that every single possible universe occurs. They believe every single possible universe occurs an infinite number of times. There's an infinite number of duplicates of every single type of universe. So it's not just, again, Alan Guth says everything that happens an infinite number of times.
Everything's possible. It happens in the multiverse, and it happens infinitely many times.
Right.
Exactly.
So that's the key. So since every single universe has an infinite number of duplicates, so which universe is typical? What is the most likely intelligent observer, the common intelligent observer you're going to get if there's an infinite number of every single universe, exact duplicates? It's impossible to make any straightforward probability. It just mathematically, it's just not possible. And that's where the only way you can do this in mathematics, and this is what multiverse scientists do, is by introducing something called measures. So measures are really external constraints, an ad hoc thing that you add onto a system, and they're just intrinsically, meaning they intrinsically come separate from the laws of nature. So, the laws of nature, according to scientists, are eternal inflation and string theory. They produce an infinite number of universes, which have all different laws and constants, and every single thing happens an infinite number of times. But then there's this measure which says certain kinds of universes are more common than others. And it's just an external rule imposed upon it. So, for example, it would be like saying for every 3 silver marbles, take 1 gold marble. 3 silver marbles, 1 gold marble. 3 silver, 1 gold. So then if you just you create a pattern of 3 and 1, 3 and 1, and then even if it's an infinite pattern, so that goes on forever, you'll have an infinite number of both marbles, and it goes on forever. But after, let's say, 1,000,000 marbles, that's where the cutoff comes in. So after 1,000,000 marbles, let's just cut it off. Let's just see what's the ratio after 1,000,000, 3 to 1. After 10 million, it's 3 to 1. Okay, that's the cutoff. We're using a finite cutoff and taking probabilities, and it turns out there's a 3 to 1 ratio. Yeah, because you've imposed a pattern on it through that measure. And this is, it's just, measures have many problems associated with them. And Paul Steinhardt, who was one of the originators of inflation, he wrote he article about, rejecting eternal inflation and the whole theory of inflation, because it leads to this thing called the measure problem. And we're not making it up. We're not making it up. There are real scientists who reject multiverse for this reason. And the first reason, the measure problem has 3 problems. The first one is that the whole thing is totally arbitrary and it's ad hoc. It's something that's put in externally to the system in order to allow multiverse scientists to calculate probabilities. Because if they can't calculate probabilities, they can't make a prediction. If they can't make a prediction, then they're just a naive multiverse, which just says everything and anything happens. So the whole thing is just some ad hoc addition in order to make multiverse science work out. So that's the first thing. It's really unjustified.
Second thing is that when they actually try to make measures and they try to come up with measures and to test to see whether our universe is typical, and all the measures which they tried to use or that they've tried so far resulted in the fact that our universe is not typical. It's more typical to have ultimate brains or to have other types of universes. And the idea is that even though given that the whole thing is ad hoc, but even when they attempt to do this ad hoc measures and they make these measures up, whenever they make their calculations, all the ones that they've tried end up resulting in that our universe is not typical. And that a prediction is that we would find this until the universe. It's not true. So they're not working. The whole approach is not working.
And they've been trying since the 1980s. This is not something they've been doing this for decades. And they've tried all these intuitive measures, the volume measures and the youngness measure, all these different types of measures that they could use intuitively. And then it doesn't predict that we'll be typical. It predicts that something else will be typical. So they crumble that up, throw that in the garbage, and start again looking for another measure. And they still have not found, even though the whole idea of measures are ridiculous to begin with, it's just totally ad hoc, unjustified. But even within that framework, they haven't actually found the measure which makes our universe typical in a multiverse. So that's the second problem. There doesn't actually exist a measure that would make our universe typical.
And then the third problem is, so what do? Their idea is that the physicists, the multiverse scientists are hoping that one day they're looking and they're hoping to find the measure, which is going to end up making our universe typical. And the problem with that is, and this is the point you were alluding to before, Jeff, is that itself is another form of fine-tuning. Is let's assume one day intelligent scientists do a lot of work and they end up finally, after dozens of years, finding the right measure which makes our universe typical. And now they're saying is, so our universe works by this fine-tuned measure, this special measure, and that's how you're explaining everything in our universe. Well, then you beg the question, what fine-tuned that measure? What shows, what determined that our universe works by this special measure? And that itself is an argument for an intelligent cause, because our universe would be the measure which would really govern this infinite varied multiverse would be this special fine-tuned measure that results in the universes like ours, those being typical. And even if they were to find that, they just push the problem of fine-tuning back one step, and they haven't really solved anything.
Well, it seems to me there's an even bigger parallel to your discussion, because your original discussion was there are these numbers we just have to put in, and we find those numbers must take exacting values. And so you move to the multiverse, there's this measure that we just have to put in, and that measure must take exacting values. I mean, you haven't solved that problem. You've just translated it to a different area. I think that's a pretty remarkable development in this whole process.
Right. Yeah. And basically, when it comes down to, and again, the measure problem is Susskind says it's a major problem, even though he still believes in it. Steinhardt just rejects the entire thing outright because of that. Again, this is a major problem for multiverse. And it just shows you that multiverse is not real. It's just not real science. The whole thing is this. Yes, internal inflation produces infinite number of universes, and maybe string theory, if string theory is really true, who knows, would allow the constants to change. Even if you grant scientists all those things, it still doesn't work out, because you can't just say in the infinite multiverse everything happens, and therefore that explains why we exist. It's not true. That's not good science. That leads to ridiculous paradoxes and absurdities and magic spells and things like that. They have to add on this typical universe premise. And then in order to make a calculation with an infinite number of universes, you have to introduce these measures, which are bad ideas to begin with, which don't even work. And even if they were defined, it wouldn't solve anything. So the whole thing is just, it's built on such corrupt foundation. It's such a faulty foundation that you just start to realize that why are scientists believing in this? How could the greatest minds of our generation all of a sudden believe in this infinite number of unobservable universes? It boggles the mind that they do. And you start to realize the only reason that they actually believe this is because you have this significant problem of fine-tuning of the constants of nature, design of the laws, and the initial conditions, like what we spoke about on our first series of an intelligent cause. And there's no other explanation other than intelligent cause besides this multiverse. This is literally what they're left with. They realize there's no other answer, and they just think God is impossible. They know, they've been taught, they understand that God is an impossible idea. It's illogical. It doesn't make any sense. And therefore, they really feel that multiverse must be the solution, because, and they're right, if God is impossible, then it's got to be a multiverse, even how ridiculous multiverse is. But again, they come in with this unjustified premise that God is an impossible idea. And I think that's the only really reason why multiverse scientists really believe in something that's just so far from what classic science used to be, which demanded observation, experimentation, and now to believe in this kind of stuff like multiverse, it's only because there's no real alternative to an intelligent cause besides the multiverse.
We're going to wrap up here, but I do have one just quick question that I've wondered in our discussion here, because it seems to me there's two aspects of this. One, does the multiverse, in doing science that way, solve this problem? And I think we've had a great discussion on that. There's the other question of, might we live in a multiverse? Might God have actually created a multiverse? I'm going to give you guys each like a minute to answer. I'm just curious what your thoughts are off the top of your head. That might be an interesting future discussion on A Star, Cells, and God. But what are your thoughts before we close here?
Okay, I'll take that one first, though. Okay, I would say that it's possible. You'd have no justification, no evidence for it, but it is possible that God made many, many other universes that do not causally interact with us. But then those other universes are also ordered, and there's wisdom and intelligence in it. But you see, by God's actions, he makes incredible, intelligent, amazing world filled with wonders and amazing things, from galaxies and stars and black holes and planets, just amazing, awesome things. So it's possible there's other universes that we don't interact with. But I would say then it would follow the same type of pattern, it'd be full of wisdom. If you mean by a multiverse where there's an infinite number of other universes and they're all garbage, and just by chance there is one universe like ours, and just God made that, I would just say that, and I hope I don't offend anybody, if that's what God did, I would say he's infinitely powerful because he can make all these universes, but infinitely stupid because he wouldn't know what he's doing. He's just making infinite amount of garbage, and by chance you end up with something nice. That's not intelligent. That's just infinite amount of power with stupidity. You don't know what you're doing, and by chance you end up getting a universe with something good in it. That's not an intelligent way of doing something. So I don't think an intelligent God would make an infinite varied multiverse. That would be an all-powerful, stupid God. But I think the God that does exist, the reality of God, is who made one universe, as far as we know, filled with wisdom and intelligence. And it is possible, though I have no evidence for, there's a lot of other universes, but I would say they're also filled with intelligence and wonders and amazing things.
I appreciate that. Thanks.
Yeah.
what he said. All right.
People get upset if I say that. But.
No, I appreciate that. I do think it would be an interesting discussion because I think this discussion, particularly in light of does the multiverse actually explain the fine-tuning? We've just had a fascinating discussion. I really appreciate your insights. Thanks for joining us here today.
Yeah, I'll say one thing about that, Jeff, is that in season 3, we're doing season 2 now. Season 3 will probably be like in another year or so. We're going to have a whole season dedicated to the idea of God and presenting a clear, logical, intuitive idea of God that emerges from the fine-tuning argument. And that you can use categories of physics and the categories of science to show that they transfer to the idea of God and metaphysics. And we're going to develop, just like we spent in top 10 episodes about the fine-tuning argument, and we're going to have about 14, 15 episodes on multiverse. In another year or two from now, we're going to do a season 3 about God, and it's going to take up all these types of questions. So,
nice.
I think it's important. You can't just not talk about God. The reason that scientists don't, believe in multiverse, don't accept fine-tuning, because they think the idea of God is impossible. And therefore, in order to make this argument complete, you really have to present a clear, logical, coherent idea of God in order to satisfy a rational, philosophical, scientific mind.
Right.
No, I would agree with that. I think there's lots of ways where people misunderstand God and who the God of the Bible is and how that plays out. So I'm looking forward to see what you do there, and really do just appreciate you joining our show today. And I want to encourage those who are listening to join our discussion in the comments below. We love that you watch Star Cells and God, want to hear your reactions and comments on that. Remember to like this video and subscribe so you can get more content. Star Cells and God releases each Wednesday, so get your reminder so that it shows up. It's here on YouTube, your favorite podcast app. Remember to share this video with friends, have great discussions around it, and remember, the more we know about science, the more reasons we have to believe.